we would call this linear algebra. Everything we did in intro basically would be graphed into a line. Okay, what we just finished, systems of equations, is the end of linear algebra. It's kind of, basically it used every skill that you learned in every chapter of intro in one chapter. That's what made it so hard. What we're about to start is nonlinear algebra. Okay. So basically in linear, every single thing we did pretty much equated to a line. In nonlinear algebra, we are going to do some graphs. They're not going to be lines. Okay? And so what we need to do is basically start at the beginning of nonlinear algebra. And so we're going to learn some rules on how things work. And a lot of things on nonlinear algebra, we're just going to do like the level 1s and level 2s. And there might be 10 levels of those problems, but it's algebra 1. And so we're going to do level 1s and level 2s, and you're going to do the other levels in algebra 2 and algebra 3. So some of the things we just won't get far enough to actually be able to use them very much in a real life scenario, but we're going to begin it. Okay, some of the stuff is real easy. Some of the stuff is hard. And so we'll just have to figure out which is which. Okay, for our purposes, we're going to start with multiplication properties of exponents. You have done these before, although we might be getting close to where you stopped doing school last year. I'm not really sure what you left off, and I bet you guys don't know what you missed, right? Because you weren't at school. So we might run into some barriers. That's why I gave you this test. It's not going to count like a test, but I gave you this test just to see if you know how things work, especially with the square roots. Because like if I need to teach pre-algebra square roots, I will. If I need to teach pre-algebra exponent rules, I will. So that's kind of what we're looking at. Okay, so the first rule, because we're going to have a set of rules, and you need to get used to this because geometry is all rules. That's all we do. The first rule we're going to deal with, and so I'm going to call it rule 1, and I'm going to give it a name. If you can't memorize the name, that's okay. Don't care about the name, because they all are very, very the same. Okay, that's the first rule. And I guess we should probably go over basically what we are wanting to know how to do. So on your little test here, we had basically stuff like this, right? Okay. Or we had stuff like this. Okay. So I need you to know that this and this, those big numbers are basically called the base. Okay? And you can't see that. These little numbers are called the powers. So I might say 2 to the second power, or 4 to the fifth power. Okay? So we're going to start with the product of powers. And we are in chapter 6. So that means we're getting through this book. And we will finish it. Okay, the product of powers, this is how it works. I'm going to write it out, and I'm going to write it out in a expanded form as well. So, here we go. Okay, so that's basically, it's written kind of in a formula. What it states basically is if you're multiplying like bases, then you are going to just add the exponents. Okay, so I'm going to give you an example that might make sense. We're going to do 2 to the 4th power times 2 to the 3rd power. Okay. This is how you might have done it in pre-algebra, in 8th grade and 7th grade. You might have written it in expanded form, so I'm going to write this in expanded form. This is 2 times 2 times 2 times 2. Is that right? That's what that means? Yeah. Then I'm going to put a multiplication symbol, and this means 2 times 2 times 2. Yes? What is that going to equal? Well, there's 1, 2, 3, 4, 5, 6, 7 2's. So this would be 2 to the 7th power. Okay. All right. We don't want to do it the long way. We want to do it the algebra way. And so what I'd rather you do this. I'd rather you do 2, 4 plus 3, which is going to equal 2 to the 7th power. Okay, do you see what I just did? Okay, so multiplication of the bases means add the exponents, and that's how it works. Okay. The second one, and we're going to do just 3 rules today, and we're going to do the easy version, and then we're going to do another notes where we're going to do kind of the harder version where I'm going to go over stuff. Okay, the next one is called the power of powers. It's a lot of powers. Okay, so this is how it's going to look. A to the m parentheses to the n. Okay, normally when we have 2 things on either side of a parentheses, what do we do with those numbers? We would just, yeah, I guess we would distribute, yeah. But like, for example, if I have 2 numbers like this, what do I do? Multiply. Yes, I multiply, right? So that is also going to be true with the power of powers. So this is going to be A, m times n, so okay. So I'm going to do one of these. So we're going to do 3 to the, we'll call it 4, and then we're going to call it 3 outside here. Okay, I'm going to write it in expanded form. What this means is how many of this means this. 3, 4 times 3, 4 times 3, 4. Or you could write it like 3, 3, 3, 3 times 3, 3, 3, 3 times 3, 3, 3, 3. So what is that going to equal? 3 to the what power? Okay, so that's a lot of work, and our goal is not to do a lot of work. Our goal is to get it correct. So we're going to do it the algebra way, which is just do 3, 4 times 3 equals 3 to the 12th. Okay, so if there's a parentheses like this, it's multiplication. If it's just like this, you add the exponents. Of course, we're only dealing with the exponents right now. Okay. So here's the last rule we're doing today. This is called the power. Let me see what it is. They all have powers and products and stuff like that in it. This is called the power of product. And the reason why I'm giving you these titles is because you can Google this stuff and you can get all kinds of examples and all kinds of people teaching it online. So if you're really confused by something, if you have the proper titles to them, you can search it. So this is how this one works. And I call it, it's not really this, and so no one else calls it this, but I call it basically the distributive property of exponents, because it's kind of right. It kind of works like this, but it's not exactly the same. So it's not really this, but I call it that because it helps me think about it. So this is an example problem. We're going to have A, B, C. And we'll have to the m power. And so this is going to equal A to the m, B to the m, C to the m. Okay, see how I distributed the m to each one of these? Okay, and so we'll look at a problem like this. 2xy to the fourth power. Okay, so this would be 2 to the fourth power. I'm basically just going to go bam, bam, bam. 2 to the fourth power, x to the fourth power, and y to the fourth power. Okay, make sure this is a little low. I'm going to rewrite that. Make sure that you know that's 2 to the fourth power, x to the fourth, and y to the fourth. Okay. So those are the three powers we're going to work at. And so we're going to do some example problems of what we're going to have to work. I think we're going to work 21 of the easier problems, and then we're going to kind of check them over, and then we're going to do the more complicated problems. Can I move on? Okay. So I like to view this as kind of puzzles. Okay. And so we're going to start off with something pretty easy here. Okay. All right. So the first thing I want to do is I want you to realize that everything has an exponent. Okay, we didn't deal with that before because we were dealing with linear algebra. But like 4 has an exponent, it's 1. 4 to the first power is 4, correct? X to the, it also has a 1. Okay, so go ahead and always put the power above everything. That way you know exactly what you need to do. Okay, so this should be a piece of cake. All right, so the first thing I'm going to do, and I'll write that down. First thing I'm going to do is write write unique bases. Okay, write unique bases. And so in this case, I'm going to write, I have a 4 and I have an x. Do I have any other more unique bases? That's the first thing I want to do. Okay. And the second thing I want to do, well, in this particular problem, I'm going to add steps, but in this particular problem, it's just add powers. And so we'll kind of add to this list, and it'll eventually be longer, but for now, we can have this. Okay, so here we go. Well, I only have 1 4, and this would be 1 plus 5. So my final answer is going to be 4x to the 6th. Okay, let's try another one. Okay. First thing I'm going to do is write my unique bases. I have a 3 and I have a x. Are those my only unique bases? Okay. I'm going to label these. Okay. So I'm looking at 3. I'm going to do 1 plus 1. 1 plus 1. And x, I'm going to do 3 plus 4. Okay. That's going to be 1 plus 1 is 2. 3 plus 4 is 7. Okay, and I'm going to go one step further. What is 3 squared? You can go ahead and do that, right? Okay, so that's those kind. Okay, we're also going to do problems like this. So again, I'm going to write the unique bases. What does this mean? It means multiply, right? So that would just be 6 times 5, otherwise known as x to the... Okay. So now I'm going to move on to the last example. Let's see what we're going to have here. Let's do 2. And we'll do a different letter. 2k. And so it's going to 2k to the 4th. And this is going to be 3. Okay. Again, I'm going to put this 1 so I remember it. So this is kind of combining two things. So I'm going to do the distributive property. Okay, so this 3 will go with this 1, and this 3 will go with this 4. Okay, so this means it'll be 2 to the first power times 3, and k to the 4th power times 3. Okay, and so that's going to equal 2 to the 3rd power, k to the 12th power, and I can do 2 to the 3rd power with my calculator. That's going to be 8, and that's going to be k to the 12th. Okay, that's that. Okay, we're going to start with basically at that level, and then we're going to expand it, make it a little bit harder, but not add any more rules today. We're just going to make more complicated problems. So our goal is to eventually learn all the rules and be able to simplify. And so we're going to spend basically most of this week on these rules, and then we're probably going to take a quiz Friday, because really there's just not a lot to them. And then we're going to move on to other things. We're going to learn how to graph something that is not linear. And it'll be okay because it'll be like a level 1 graph and not like a difficult graph. Just a second.